This is the editorial to CSES Problemset apartments. In my last recording, I accidentally submitted a wrong file, and took me a while to notice that. So here I am making a second recording, but that's alright. Here. So this is the problem. There are n applicants and m free apartments. Your task is to distribute the apartments so that many applicants as possible will get an apartment. And each applicant has desired apartment size, and they will accept any apartment whose size is close enough to the desired size. So basically, these numbers are the desired apartments, and these are the available apartments. And each desired apartment wants an apartment that's at least k between, there's at least at most k values in between the apartment size and the desired apartment. So basically what they're asking for is an apartment that's so absolute value between the apartment sizes are at most k, if that makes sense. But yeah, okay, so these are the inputs. We'll read them in, and then that's just my template. Yeah, so you don't really have to worry about it. But okay, so first values are n, m, and k, sin, m, and k, and then these are the desired apartments, right? And so desired apartments are I'll just store it in R. Right, so okay, so here, before we go on to storing these values, we have to do something, which is I'll have to explain why we're gonna do it, right? So here, so basically the way in which we're gonna solve this is by having, so these are the desired apartments. Sorted will be 60, or 45, 60, 60, 80, right? So I'll just delete that, and then this is already sorted. So what we want to do is we wanna for each value we want to search a value that's in between the values v minus k and then v plus k. So v being the value we're looking at right now. So for example, if v is 45, we want to look for 45 minus k, in which case k is 5, so 45 minus 5 and 45 plus 5, right? So that'd be 40 and 50. So we're looking for those values, and instead of storing these as just a normal array, we want to store these as sets or multi-set, so that when we look up the value, we can look it up using binary search and make it faster. So if we were to look it up using just normal vector, it'd be on. However, by looking it up using sets or multi-set, we get O of log n, which is, well, way faster, right? Okay, so that's exactly what we're gonna do. So, and one thing to be careful here is that we want to store the available apartments using a multi-set, which basically stores so here. So what sets do is they only store distinct values. So let's say we have 36. I'll just do 1, 2, 3 in the current set. If we were to append 1 into the set, that would still make it 1, 2, 3, because it ignores any value that's already in the set. So only stores distinct values. However, with using multi-set, let's say we were to append 1 into the same values, same list of values, we would get 1, 1, 2, 3. And why is that necessary in this problem is because for apartments we can have it doesn't specify that the apartment sizes are going to be distinct, and we want to store all the apartment sizes, right? We don't want to just store one value for like we don't want to just store distinct values. We want to store every value, so we're going to use a multi-set to do that. So here I'll just code it out. Multi-set of int of available, right? And then for int I equals m, okay. And if you see why I'm getting these pop-ups, that's because I already coded it on the last try, but as I said, I submitted a wrong file, so yeah, that's why I'm getting these pop-ups, because a VS Code, right? Yeah, a VS Code that I'm using basically does that. It gives me pop-ups when I've already used certain, I guess, letters, characters. Yeah. So yeah, okay. So now we'll iterate over the values, right? So int a equals the ri, and we'll sort r just to make it easier for me, so we can like we can confirm. I don't know. I think sorted, just we can make it so that if we see a certain value that doesn't work, we can just break out of the loop. So well, just ignore that part. All right. Is auto it, so dot lower bound a minus k. So what this does is we just this basically looks for values that are lower than, or I mean larger than or equal to the value we inputted, which is a minus k. And if n, we can just break out of the loop, and then else well, yeah, so if absolute difference between it and what a is smaller than or equal to k, answer plus equals 1, and available dot erase it, right? And then we'll just declare answer. Wait, no, see how answer. Yep. So here you can just search up sets and multi-sets. Geeks for Geeks has a good tutorial on it. But what lower bound does is it basically looks for value that's lower than or greater than or equal to the value inputted, and then it does it in log n form, because the set is already sorted, so it just uses what's that called, binary search, to look this value up. And why we break the reason for why we break the loop is because if the value we're looking at currently does not have a value greater than this value, so it does not have an apartment greater than that, greater than or equal to means that any other apartment after this value will also not have it, because this r, the desired apartments, are sorted, so it makes it easier. That's why I sorted the values, so I can just break out of the loop. And I think you need to sort it for it to work. I'm not sure, but yeah. Here, we'll submit this. I have to get the right file, and then here. I hope it works. Yep, it did work. I'll leave a link for multi-sets and set in the description. And then one thing to note is that many of these sorting and searching problems in CSES and many other, like, I guess, places usually require the use of sets and multi-sets or maps, because it makes it way far faster to search values, right, using binary search. So that's, well, yeah, I used maps in the last video, and I use sets here. So yeah, so make sure to know what they are, and well, yeah, that's how you solve the problem. Bye.